All right, guys, so in this video, we're going to go over the review for your quiz tomorrow. Already you should have gone through your review sheet and answered the problems that you know. And now I just want you to check your work with this answer key that we're going to go through right now. All right, so look at number 1. It says, in a theater, for every 5 popcorns sold, there are 2 pretzels sold. So I can see that it says 5 popcorns, 2 pretzels. What I like to do is just make a quick key, just to use as a reference. So I know that popcorn is 5, pretzels is 2, which makes my total food 7. So now I can just use that key to answer these ratio questions. So A says, write the ratio of popcorns to pretzels. So I can go to my key. Popcorn is 5. Pretzels is 2. So my ratio is 5 to 2. For B, it says, write the ratio of pretzels to total. Since I already have everything in my key, pretzels is 2. Total 7. For C, it says write an equivalent ratio to answer B. So answer B, my ratio is 2 to 7. For an equivalent ratio, I know that I can multiply or divide. So I'm just going to note that. So make sure you write that too, multiply or divide. But I know that 2 and 7 don't have a greatest common factor. It's already in simplest form, so I'm just going to multiply. So I can multiply by 2. So if I do times 2, I'd get 4 to 14. You could do times 5 and get 10 to 35. You could do times 10 and get 20 to 70. So whatever you do to the first number, you have to do to the second number in order to get an equivalent ratio. So any one of those or any number you pick would work. Okay, look at number 2. It says for every 4 treats that Daisy gets, the cats get 6 treats. So letter A asks you to determine a ratio to describe the amount of treats that Daisy gets compared to the amount of treats that the cats get. So I'm again going to make a quick key. And I'm going to have Daisy is 4. Cats are 6. Total is 10. So the ratio of Daisy to cats, I can just look here, or I can look back at my problem if I want, is 4 to 6. Now B says, if the cats get 24 treats, how many treats would Daisy get? Now this is asking for more information, so you can do it 3 different ways. So I'm just going to show you. A lot of you like to do the part total more chart. So you can do Daisy to cats is 4 to 6. Your total is 10. Your more is 2. And then it says that the cats get 24 treats. So you'd match up the 24 with the cats, which means everything is times 4. 8, 40, 16. And the question is, how many treats would Daisy get? So you look at your Daisy column, and it would be 16. Now, an easier way that you could do this is you already have 4 to 6. So you know that there's 24 treats for the cats. So we have Daisy to cats. So you could do an equivalent ratio here of Daisy to cats. And we know that 6 times 4 gave us 24. So we also have to do times 4 with this 4, which also gives us 16. So either way, you'd get the same answer. You can also do a tape diagram, which I'm not going to show that, but if you prefer to do that, you can as well. So letter C says, what's another possible ratio that describes the number of treats Daisy gets compared to the cats? So that's basically just asking for an equivalent ratio. And in order to find that, you know that you can multiply or divide. So I can take my original ratio, 4 to 6, and I can divide. So if I'm finding another ratio that describes these treats, I can divide by 4, I can divide by 2, which is my greatest common factor. That would give me 2 to 3. So there's a possible ratio. I could also take my 4 to 6 and multiply it by 2, which would give me 8 to 12. That's another possible equivalent ratio. You can multiply by 5, you can multiply by 10. Anything you do to the first number, though, you have to do to the second, and that gives you another possible equivalent ratio. All right, let's look at number 3. A school bus has little kids and big kids. For every 4 little kids, there are 10 big kids. If there are 30 more big kids than little kids, then how many are there of each? So they give us the amount of little kids, they give us the amount of big kids, and then they say that there's actually 30 more. So I'm going to go ahead and do, it says to use a tape diagram, but you can use any method that you choose. All right, so I'm just gonna go ahead and do the part total chart. All right, and it's comparing little kids to big kids, 4 to 10. My total is 14, and my more would be 6. So then the actual info, be careful, because it says 30 more. 30 more. So that 30 has to match up in your more column, which means everything is going to be times 5, which leaves 20, 50, 70. Okay, so then the question is, how many are there of each? Well, the number of little kids, I go to my little kid column. We have 20 little kids. Then it says how many big kids? I go to my big kid column, and then there's 50 big kids. So you can use a tape diagram if you prefer as well, but the part total more chart will show you exactly every part to use. All right, number 4. The ratio 10 to 4 indicates the ratio of the number of kids that like gym class to those who don't. So we have like to don't, and we've got 10 to 4. The extra info is that if there are 28 kids that don't like gym class, then how many like gym class? All right, again, use a tape diagram, can be any method. Any method. So I'm just gonna show using a part total more chart. So we're comparing those who like gym class to those who don't, is 10 to 4. My total is 14. My more is 6. Then it says 28 kids don't like gym class. Here's my don't. So everything is going to be times 7. Fill out my charts. Everything's multiplied by 7. And the question was, how many like gym class? How many like? There we go. 70 kids like gym class. And I would just say 70 like gym. Okay? Number 5. Newburgh has lots of different weather. In the fall, the number of nice days to bad days is 4 to 6. In the summer, so we have fall and then the summer. In the summer, the ratio changes. So in the summer, for every 8 nice days, there are 2 bad days. If there are 30 bad days in the fall, there's our extra info. 30 bad days in the fall, then how many are nice in the fall and in the summer? There's our question. How many are nice in the fall and in the summer? So that's a lot of info, but I know that it's going to be a change of ratio. So look, we've got 2 ratios, 4 to 6, and then we've got 8 to 2. So we need to do 2 different charts. So I'm going to do a fall chart. And I'm going to do a summer chart. All right, so we have comparing nice days to bad days. Nice days to bad days. Total, more, total, more. In the fall, it said 4 to 6 with a total of 10. Difference, or the more of 2. In the summer, it said 8 nice to 2 bad, which gives us a more of 4. And then it says if there are 30 bad days in the fall, so I'm going to go to bad days in the fall, and my 30 is going to go right there. So everything is times 5 across both charts. Then I'm going to go through 20, 50, 10, 40, 10, 50, 20. Notice how your totals are the same, 50 and 50. And then the question is, how many are nice? So I'm going to look at the nice columns in the fall and in the summer. So right here, the number of nice days in the fall, well, that's going to be 20. And then the number of nice days in the summer, that's going to be 40. Okay. Let's go to the back. Okay, so on the back, let's look at number 6. It says, a TV show has many great acts. For every 5 male contestants, 5 male contestants, there are 7 female contestants. If the show has a total of 60 contestants, then how many of there are each? And it says to use a tape diagram, but you can use any method to solve. So I'm just going to show it using the part total more chart. You can use the tape diagram, you can use the mountain valleys, whatever you decide. So we are comparing male, which is 5, to female, which is 7. Our total is 12, and our more is 2. So the extra info they said is a total of 60. So I'm going to go to my total column, put 60, and everything is going to be times 5. So we've got 25, we've got 35, and we've got 10. So the question is, how many are there of each? So it says the number of male contestants. I go to my male column. We've got 25. It says the number of female contestants. I go to my female column. We've got 35. So number 7, it says the ratio of hard ice cream sold to soft ice cream sold is 7 to 5. So we're comparing hard ice cream to soft ice cream, 7 to 5. It says if there's if there's 20 soft ice cream sold, then how many hard ice creams would be sold? So our extra info is 20. Our question is asking for how many hard. So I'm just going to show again using a part total more chart. We've got hard ice cream to soft ice cream is 7 to 5. Total would be 12, and more would be 2. So it says 20 soft. We're going to go to soft, which is 20, and it's going to be times 4. So we're left with 28, 48, and 8. Okay, so the question is how many hard ice creams? 28, we go to H for hard, 28 hard ice creams. Okay. Okay, so let's look at number 8. It says create 3 equivalent ratios for 4 to 12. So I know when it's asking for equivalent ratios, you're looking to multiply or divide. Okay, so if we're only looking for 3, you can choose to multiply or divide. You can multiply twice, divide twice, it's up to you. However, I like to always find the greatest common factor first and find it in simplest form. So I know between 4 and 12, my greatest common factor is 4. So 4 divided by 4 is 1. 12 divided by 4 is 3. So there is 1 equivalent ratio to 4 to 12. Now, I also know that I can divide by 2. So if you had 4 to 12 and you decided, they're both even numbers, I can divide by 2. 4 divided by 2 gives me 2. 12 divided by 2 gives me 6. There's another equivalent ratio. Now, it's not in simplest form, but it is still equivalent. So I can also multiply to find equivalent ratios, and you can do times 2, you can do times 5, times 10. As long as you multiply the first and the second number by the same number, then you will find an equivalent ratio. So 4 times 2 is 8. 12 times 2 is 24. So there is my third equivalent ratio. You may have gotten other answers, which is fine, as long as you multiplied the first and the second by the same number, or divided the first and second by the same number, and it came out evenly. So now look at number 9. One of my students, we will just call him Jay, really loves Carmelo Anthony. The ratio of his Carmelo Anthony basketball cards to Carmelo Anthony fatheads is 3-8. So if Jay has 48 fatheads, then how many Carmelo Anthony basketball cards does he have? So I can just do a regular part total more chart. And I'm comparing basketball cards to fatheads in the ratio of 3-8. My total is 11, and my more is 5. So the extra info is that there's 48 fatheads. So I'm going to go to my fathead column, 48, and everything is times 6. So 3 times 6 is 18, 11 times 6 is 66, 5 times 6 is 30. So my question is, how many basketball cards does he have? So I'm going to go to basketball, and my answer would be 18 basketball cards. Now the second part of the question says, determine the value of the ratio from the previous answer. So I know that the value of the ratio, sorry, I'll bumpy. The value of the ratio is basically saying simplest form. And in order to find your simplest form, you need to first find the greatest common factor, and then you second need to divide. Okay, so I'm going to look at our newfound ratio of basketball cards to fatheads, which is 18-48. And a lot of you will be able to use a calculator for this. So you want to find the greatest common factor first. So by using the Euclidean algorithm, you would just do 48 divided by 18. And you'd see 2.66667. So you're going to use the whole number of 2 and find out that 18 times 2 is going to give you 36. When I subtract, I'm left with 12. All right. Then I have to go again because I do not have 0 as a remainder. So I'm going to do 18 divided by 12, which leaves me 6 as a remainder. So I'm going to divide again. 12 divided by 6 finally gives me 0 as a remainder, which means 6 is my greatest common factor. So I can take 18 divided by 6. I'm going to take 48 divided by 6, which if you look was times 6 in your chart. So 18 divided by 6, if you go backwards, gave me 3. 48 divided by 6 gives me 8. So the value of my ratio is actually the starting ratio of 3-8. That's our value. Okay, number 10. There are 1,000 kids at school. Of those students, 1/4 of the kids walk to school. What is the ratio of the number of students who walk to school to those who take the bus? So you're going to make a key, and you're going to have the total. You're going to have the kids who walk to school, and then you're going to have the kids that bus. All right, so you know that the total is 1,000, so you can fill in 1,000. But it says of those students, 1/4 of the kids walk to school. So in order to figure that out, you have to take your 1,000 and divide it by the denominator of 4. All right, so if you have your calculator, you can do the long division or take your calculator. 1,000 divided by 4 gives you 250. With 0 as a remainder. So 250 of the students walk to school because you divided it by 4. So 250 walk. Now in order to find out how many bus, the other part, you just need to subtract. So I'm going to take my 1,000, subtract the 250 that walk. Oop. And I'm left with 750 who take the bus, okay? So there's my key. I have all my parts now. I had to divide by the denominator of the fraction to get how many walk. Then I had to subtract to figure out the other part of how many get bused. So the question was, what is the ratio of the number of students who walk to those who take the bus. I could look at my key, 250 to 750. Okay, then the second part is what's the value of the ratio, and that again means simplest form. So I know that first I need to find the greatest common factor, and then second I need to divide. So in order to find the greatest common factor, I'm going to take my two numbers and I'm going to do the Euclidean algorithm. So we've got 750 divided by 250, and we're left with a 3, which gives me an even 750 with 0 as a remainder. So since 0 is my remainder, my greatest common factor is 250. So if I divide each side by my greatest common factor, 250 divided by 250 is 1. 750 divided by 250 gives me 3. The value of that ratio is 1 to 3. And then last, there are 600 kids at a school. Of those students, 1/3 of them hate the snow. What's the ratio of the number of students who hate the snow to those who like the snow? So I'm going to do just like number 10. I'm going to do a key again. They gave me my total. They told me that some kids hate the snow, and then they said some kids like the snow. So the total they gave me is 600. There it is. And then it says 1/3 of them hate the snow. Well, in order to find what 1/3 of the 600 is, I need to take the 600 and divide it by my denominator of 3. Okay, and you can do the long division, or if you can use a calculator. You're left with 600 divided by 3 is 200. So I know that the number of kids who hate the snow is going to be 200. And to figure out how many like, you need to subtract the 200 from the total, which you're left with 400 kids who like the snow. So then what is the ratio of the number of students who hate the snow to those who like the snow? Again, I can look back at my key. Hate is 200. Like is 400. There's my ratio. So then what's the value of that ratio? Again, value is simplest form. So first, find the greatest common factor. Second, you're going to divide. So take your two numbers of your ratio and do the Euclidean algorithm. So 200 times 2 gives me 400 with 0 left over, which means 200 is my greatest common factor. So I can take my ratio and divide both numbers by 200, and I'm left with 200 divided by 200 is 1. 400 divided by 200 is 2. There's the value of my ratio.